AlphaGo, Will You Marry Me, GPT? A proposal for solving problems with ground truth signals, like maths and coding. AlphaGo and ChatGPT are the most successful AIs recently. AlphaGo is the first program to defeat a world champion in the game of Go. AlphaGo Zero achieves superhuman performance in Go, starting tabula rasa. AlphaZero defeats a world champion program in the games of chess, shogi, and Go, starting from random play and without domain knowledge except game rules. The key techniques of AlphaGo are deep learning, reinforcement learning, policy iteration, self-play and Monte Carlo tree search, MCTS. The details of AlphaGo series are very involved. Stay tuned for explanation in a later video. An autoregressive language model is defined by the conditional probability distribution of next token, given previous tokens. It is a policy, in the language of RL, where state is the previous tokens and action is the next token. The transformer is the backbone of large language models and foundation models. GPT stands for Generative Pre-trained Transformer. Self-attention facilitates long-range dependency. The transformer architecture is conducive to large-scale implementation. GPT started at OpenAI with a small team until GPT-3, reaching 1 million users in 5 days. ChatGPT has taken the whole world by storm. Shall AlphaGo and GPT be together? Why not? Very promising. Some caveats though. Ground truth in the loop is a basic scientific principle. We need trustworthy training data, dependable evaluation feedback and reliable world model or verifier. Examples of ground truth signals: game scores, code interpreter, compiler. Examples: unit test results, maths verifier, problem solutions, human, especially expert feedback. Note: LLMs are not ground truth, yet. There is a simulation to reality gap between a learned and the real model, studied in robotics and RL communities. The same for LLMs. It has not caught enough attention yet. Lessons from AlphaGo, AlphaGo Zero, AlphaZero, perfect game rules so that perfect model so that infinite high quality or perfect data. It follows trial and error, with general policy iteration, self-play and it iteratively improving the policy. Experiments results show that imitation learning is far from enough for the game of Go. AlphaGo and previous programs like Crazy Stone use expert moves as training data. However, the ELO scores are much lower than AlphaGo trained with reinforcement learning and MCTS. In the figure, AlphaGo Zero achieves the highest ELO score. It is trained without any expert moves. Will synthetic data help? It depends. It helps if there is a perfect world model, a perfect simulator, like a game rule or a physics law, or there is a perfect verifier. Otherwise, it is unclear, or it may be harmful. There are more challenges like prohibitively large search space, infinite action space, no direct application of self-play, a failed trail may not contain much information. However, there are already some progress, just like before a proposal. GitHub Copilot, powered by OpenAI Codex, competition-level code generation with Alpha Code, Code RL, mastering code generation through pre-trained models and deep reinforcement learning, planning with large language models for code generation, GPTF, an automated prover and proof assistant, Lean Dojo, theorem proving with retrieval augmented language models, DT Solver, automated theorem proving with dynamic tree sampling guided by proof level value function. Two recent achievements of concrete maths problems based on AlphaZero, matrix multiplication and sorting algorithms. In this way, we build specialized models, follow a modular approach, potentially with small models, like 7 billion parameters or at the level of millions. In short, specialized, modular and small. A reflection with the progress of reinforcement learning may be helpful. RL calls for more resources to prosper. The same is true for foundational study of LLMs like its integration with RL, when and why GPT is helpful. Build a foundation model expert, policy iteration, for goal expansion, verification and evaluation as in GPTF, hypertree proof search for neural theorem proving, proof level value function in DT Solver. Retrieval augmented generation, RAG, for example, premise selection in Reprover, however, a symbolic approach in Thor, wielding hammers to integrate language models and automated theorem provers, is GPT necessary and sufficient? It is an open problem. The history of AI chess tells us that there were lots of explorations before AlphaZero. The history of computing, from ENIAC to iPhone, tells us that LLM calls for innovations, including for transformers. The history of AI tells us, learning and search are two general AI methods that may scale arbitrarily, and integration of learning and search is very powerful. Here is a proposal for problems with ground truth signals like maths and coding, with learning and search, with ideas from AlphaGo, augmented with GPT. Stay tuned for more details in a later video. Will the marriage of AlphaGo and GPT give birth to AI mathematical Olympiad champion?